This is the final take. I'm not going to do this again. I got it right this time. Alright. You see, in a normal revolution, it starts with a lot of people, loses a lot of people, and then goes to a lot of people. So in order to demonstrate this, we're going to have to make maximums. And do this, we're going to use parabolas. Now we're going to start out by using the equation y equals negative quantity x minus 2 squared plus 4. That's just this part right here. And to stop at the maximum, which is 2, it's going to go from 0 to 2. Now to find out how it is over a period of time, equal amount of time, we're going to revolve it around the y-axis, giving us this. So first thing we're going to do is we're going to do our rectangle. Going to make our rectangle. This time it's going to be starting on the y-axis because that's what's rotating around. The height is going to be dy, and the radius gets a little tricky because you'd think, oh, I can just do it from 2 and just be 2, but you can't because this middle part is being revolved and just making a kind of empty part of the volume graph. So what we're going to do is go 2, which is all of this, minus x. And x will just be what is in here, in between 0 and the graph. So now that we have that, we can use our trusty volume formula, pi times r squared times h, and plug that into an integral. So we have the integral as it goes from 0 to 4, since we're on the y-axis, of pi times 2 minus x times dy. Now once again, we can't have a dy and an x. They just don't work. So what we're going to do is we're going to go back to our equation and find out what x is in terms of y. So this is going to be minus 4, y minus 4 equals negative x minus 2 squared. We're going to take the negative on both sides. That will be negative y plus 4 equals x minus 2 squared. We're going to take the square root of both sides. Now we have the square root of negative y plus 4 equals x minus 2. We can add the 2 on both sides, and that will give us the square root of negative y plus 4 plus 2 equals x. And we can just plug this right into here for x. So then this will equal 0 to 4. I'm going to take the pi out, so that's a constant. Pi times the integral of 2 minus negative y plus 4 plus 2 times dy. And so next what I'm going to do is I'm going to distribute this negative into this a little bit. So we have the integral from 0 to 4, pi times the integral of 2 minus square root of negative y plus 4 minus 2, all times dy. Now this 2 and minus 2, both will cancel each other out. This will be squared. Sorry. And when this will then give us pi times the integral from 0 to 4, negative square root negative y plus 4 squared dy. What's so nice about this is that a negative squared is a negative. And when a square root is squared, we usually just get what's on the inside. So when you just do that, what we get is pi times the integral from 0 to 4 of negative y plus 4 times dy. And now this is so nice because we can just take the integral of each individual part. So we're going to continue this right over here. And we shall get pi, when we take the integral, pi times negative y squared over 2 plus 4y. And that's 2, 0 to 4. Now it's just plug and chug and integral solving. So we're going to have pi times negative 4 squared over 2 plus 4 times 4. We're going to subtract that from negative 0 squared over 2 plus 4 times 0. Now all this is going to be 0. And so we just have to focus on this part, which will be pi times negative 16 over 2 plus 16. Negative 16 over 2, that's 8 plus 16. 8 plus 16 will equal 24. There'll be negative 8. I'm very sorry. That's negative 8 plus 16. And that will equal 8. So we have 8 pi units cubed. And that is our volume of this revolution.